Okay, so now we're going to focus on the sums of infinite geometric sequences. Okay, so here, one thing we want to make note of right away is that r is less than 1. Okay, so when you're dealing with infinite geometric sequence, there's a particular rule that applies, and we'll take a look at it. It says if the absolute value of r is greater than 0 and less than 1, we use this formula. It's a1 over 1 minus r. Okay, so we'll take a look at it. We'll find a1 by plugging in 1 for n, so it's 5.3 to the first power, gives us 1.5. Okay, now we want to put 1.5 over 1 minus 0.3 because that's our r value. Okay, that comes out to 1.5 over 0.7. And the sum of the series comes out to something like 2.1 and then kind of trails off into the distance. So we'll just say 2.1. Alright, one of the important things, when we realize that r is less than 1, it's raised to a power. So that means this number is going to get infinitely smaller as n gets larger. So it's going to become so small that adding an additional 0.000001 is not going to make a difference in the sum. So we just say that this is 2.1 and this is a convergent sequence. All the values converge on 2.1. Here we have an infinite sum of a series in which r is greater than 1. So I'm not going to actually go through and solve this because we know that as n gets larger, say we said 5 to the third, it's 125. 5 to the fourth just keeps getting bigger. So as n gets larger, the sum of the series approaches infinity. Therefore, we don't really need to solve, and it's a divergent function.